This is Geometry A, Unit 4, Lesson 2, Properties of Parallel Lines. Properties of Parallel Lines. I have opened up here on the screen a tool called GeoGebra, www.geogebra.org. If you want to play with it, it's the Geometry app. And so I just wanted to demonstrate. We've been talking so far about transversals formed or by crossing a line, crossing two lines. So here's a line, line AB. Remember, you can name a line with any 2 points on the line, line AB. Okay, and I'm going to use the construct tools here to construct a line that is parallel to a given line. So I'm going to make it parallel to this line and through a new point C. So these lines are parallel. They're drawn so that they are parallel. And I want to analyze what happens when I draw a line, a transversal, so to speak, through both lines. Okay, so I'm going to draw a line through A and C. Okay, this line is called a transversal. Transversal crossing two parallel lines. Last lesson we named the angles that are formed, right? But we didn't really talk about them being parallel. Now they're parallel. Okay, and I want you to notice what happens when I measure the angles. Okay, so I'm going to measure the angles. I'm going to measure this angle here. Okay, 119.5. Okay, actually, it wants me to put a point on here. Okay, so let's add some points. And now measure the angle. Nope, still doing the same thing. So DAB, angle DAB, is labeled as 60.5. Okay, and now I want to measure angle ACF. Okay, and we want to compare. And you can make your own predictions, but lo and behold, look, they're the same, right? They're the same. These are called, if you recall, they're both on the upper right of their intersections, corresponding angles. So if I grab things and change them around, 85.8, 85.8, 115.1, 115.1. As long as the lines are parallel, 49.8, 49.8. Corresponding angles are congruent. Okay? And you remember the vertical angle theorem. Vertical angles are congruent as well. Okay, so let's do this here. Let's shorten that up here. Okay, and let's measure some other angles. Okay, so HAC, 63.7. GC, oh, that E is not on there, is it? It was constructed incorrectly here. There we go. Okay. There we go. All right, and let's measure the angle here. GCE, 63.7. So we've got 4 congruent angles. Okay. These two are congruent because they're vertical angles. These two are congruent because all their alternate interior angles are congruent. These two are congruent because vertical angles are congruent. All the corresponding angles are congruent. All the vertical angles are congruent. Okay? And so you can make some conjectures here. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Okay? And let me measure the remaining angles here. So we're going to measure angle BAC. We're going to measure angle DAH, 116.3. Measure angle FCE, 116.3. GCA, 116.3. Pull these out so we can see them a little more clearly here. Okay, so really what the situation is, in summary, when I have two parallels crossed by a transversal, there are only two angles that are the same. One obtuse and one acute. Now, if I make it so that one of them is right, they'll all be right. Okay, let's see if we can do that here. Make them all 90. 90 point, close. There we go. Got them all to be 90, okay? That's the exception, but otherwise, there are always 4 acute angles and 4 obtuse angles. The angles add up to 180, so same side exterior angles add to 180. Linear pairs add to 180. Same side exterior angles add to 180. Corresponding angles are congruent. Alternate exterior angles are congruent. Alternate interior angles are congruent. Okay, so that's just kind of an exploration of it. Now let's do a proof and see if we can do this fairly quickly. So we've got 2 parallel lines on our paper here. 2 parallels. And these are the rules. They have to be parallel for these rules to apply. If a transversal crosses 2 lines, 2 parallel lines, okay? If a transversal crosses 2 parallel lines, call these L and M and T. Call this angle 1, 2, 3, 4, 5, 6, 7, 8. Okay, and here are the rules. If parallel, then the following are congruent. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Okay? Same side interior angles are supplementary. They add to 180. Same side exterior angles are also supplementary. Okay, those are the rules. So let's prove that alternate interior angles are congruent. So given the drawing such that L is parallel to M, actually let's state it that way. Given L is parallel to M, prove, let's do a pair of alternate interior angles. Angle 3 congruent to angle 6. Okay, so statement. And reason. First statement, given L is parallel to M. 1, given. Okay, where do we want to end up? The last line should read, angle 3 is congruent to angle 6. Okay, don't know which step that is. All right, and let's do line 2. Line 2, if L is parallel to M, corresponding angles are congruent. So angle 3 is congruent to angle 7. Angle 3 is congruent to angle 7. And those are corresponding angles. They're both on the bottom left. So the reason or the rule, corresponding angles are congruent. And feel free to use abbreviations like this. Okay. Step 3, angle 7 is congruent to angle 6. Angle 7 is congruent to angle 6. Why? 7 and 6 are vertical angles, and vertical angles are congruent. So vertical angles are congruent. Okay? And now we're ready to do the last step. 3 is congruent to 6. So let me move that up here. I can grab it. Not rabbit, grab it. Okay, so 3 is congruent to 6. Why? Because 3 is congruent to 7. and 6 is congruent to 7. Both 3 and 6 are congruent to 7. Two things congruent to the same thing are congruent to each other. That is the transitive property of congruent. Transitive property of congruence. Okay? So there it is. So there's the proof of the alternate interior angle theorem. So if, and the big idea, if two lines are parallel and they're crossed by a transversal, if they're parallel, corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, same side interior angles are supplementary, and same side exterior angles are supplementary. Okay? The corresponding angles being congruent, that's a postulate. For that we take without proving. All the others are theorems. They need to be proven. And we just proved the alternate interior angle theorem. Okay, all right. Hopefully that helps. Feel free to book a live lesson if you need more help.